Before exploring climate change, let's look a little bit at the Earth's climate in general. Okay, so when we look at our planets and we think about the temperature of planets, a few things to keep in mind. When we look at where all of the different planets are spaced away from the sun, there's a couple of anomalies that come out. So from the Earth, the average distance the Earth is from the sun, our average temperature should be about -18. Okay, it's a little bit colder than our average temperature. Our average temperature on Earth is about 15 degrees Celsius. Now, Venus, okay, it should have an average temperature of about 100 degrees Celsius. Now, it's a little different. Its current average temperature is actually 450 degrees Celsius. Okay, all right, so Earth, a little bit warmer than we would expect it to be, and Venus a lot warmer than we would expect it to be. All right, if I look at some of the other planets, Mercury has a wide range between 370 all the way down to -150. Mars, 26.5 down to almost -130. The moon has quite a range as well, and the moon is orbiting us, so it's not that much further away from the sun than we are. So what do Earth and Venus have that Mercury, Mars, the moon don't have? Think about that for a second. What do we have on Earth and what does Venus have that these other celestial bodies don't have? If you guessed an atmosphere. You would be correct, okay? The Earth and Venus have an atmosphere. And so that atmosphere does a lot to alter what we would expect to see temperature-wise. So when I look at the Earth, we have an energy balance. Our atmosphere is going to do a lot of different things. We know that our atmosphere filters a lot of that incoming solar radiation, but a bunch does get down to us. And so the atmosphere not only filters, but the atmosphere also helps keep heat and all of that stuff in. And so we're going to get things like water vapor and dust, and ozone will do some absorption. Clouds will absorb. Clouds will also reflect, okay? The surface of our planet will absorb what comes through, and it will also reflect. And then we also emit stuff back out. And so some of the emission gets all the way out easily. Other times we get stuff that's emitting at different levels. So we've got this atmosphere that holds stuff in. Okay, and so when we look at the energy emitted from the sun, really interesting, 1 hour, the energy the sun emits could cover the energy needs of our entire population for a whole year. But there's a lot of other things that happen between reflection, absorption, reflection from atmosphere or the surface, heat transfer, evaporation, what the plants undergo with photosynthesis, all sorts of things. So we get all sorts of different things happening to that radiation that comes in from the sun. Okay, and so our climate actually has varied throughout time. We did have a lot more carbon dioxide at one point in time due to volcanic gases, but there was also less energy from the sun than we have today. Photosynthesis reduces carbon dioxide, increases oxygen, so that balance has changed. The sea level has risen, and then there's also all the short-term things that happen too. So even though we are seeing a lot of climate effects right now, we have seen climate effects in the past. It's just now the question is, okay, when we talk about climate change, what have we as human beings done? Have we actually, started accelerating what we see with our climate? And as we'll see, we have indeed caused a great effect. But we have seen a lot of variance throughout the years as well because of various different events that have happened on Earth. And then we get these short-term cycles. So like I'm from San Diego, and I've definitely gone through years where we had little to no rain, 2 years like we've had more recently where we've had more rain. And some of that is just a natural cycling, and some of that is due to us, messing with things and causing some of this change to happen differently or at an accelerated pace than we should have seen it happen.